Today, lesson 37A, equivalent numeric expressions. Our main topic so far in Unit 3 has been all about expressions. We've gone through all the properties and we've worked on creating equivalent expressions based on properties and then also simplifying expressions based on various properties. And today we just sort of extend on those ideas, but our focus today is on numeric expressions. So the difference between, and this goes back to, I think, the first lesson in this unit, the difference between a numeric or a numerical expression and an algebraic one is algebraic expressions contain variables and numerical expressions do not. And we're going to utilize, in some of the problems, the idea of the tape diagram to help us see concrete examples of the percentage problems that we're going to work on today. So just, don't forget how to deal with tape diagrams. We usually want to break it down based on a percentage that's given within a problem, and then find whatever part of that that it is we're trying to find. So let's go ahead and get started with number one. Number one says Larry has a piece of rope that's 12 feet long. And our focus today is not necessarily on finding answers. It's about writing an expression or multiple expressions that would allow us to find the answer. And that's how we're kind of starting off today's lesson. So the problem goes on and says he cuts off 25% of the rope. Or he cuts off 25% of the rope. That doesn't even make sense, does it? He cuts off 25% of the rope. That word off shouldn't be there. The question is, how long is the rope now? Now, I've started with a very easy problem. Most of you could figure that out without doing a whole lot of work there. But we have a tape diagram in our notes, and I'm going to cut that up into 4 equal parts. Why 4 equal? Well, because 25% is 1/4. So if the entire rope is 12 feet long, that would make each section of the rope 3 feet, which is obvious. But we're cutting off 25% of that. So I'm going to cut off, it doesn't matter which 25% I cut off, I'm going to cut off the first 25%. So that leaves 9 feet. But once again, that's not the purpose of today. The purpose of today is trying to come up with one or more numeric expressions that will allow us to figure out, in this case, that the answer was 9 feet. So there's 2 ways of looking at this. And one way, and we should definitely make sure we take good notes here. One way is to think of it with respect to this. Think of it like we're starting with the 12-foot section, and then we're subtracting 25% of the 12. And that's kind of what the tape diagram shows us. So the expression in red there, that's the expression that would give us the answer, thinking of it this way. 12, taking away from that 25% of the 12. So let me say that one more time. The 12 foot of rope, or 12 feet of rope, and taking away from that 25% of the 12. Because that's really what we did. That would give us 12 minus 3, which is 9. So that's one numeric or one numerical expression. Another way of thinking about this would be thinking about it in terms of taking 25% of the rope away. And if I take away 25% from the 100%, that leaves us with 75%. So this expression is basically saying, and I didn't mean to write on there, this expression right here is saying 100% minus the 25%, converting them to decimals, which leaves us with 75%. So I'm finding 75% of 12. So in most of these expressions today, there will be 2 that we want to focus on. This expression here and this expression here. And since they lead us to the same answer, and this is probably about the 10th time I've said this in this unit, these are equivalent expressions. And remember, equivalent expressions are expressions that may look different, but they are the same or represent the same value. And both of those represent the same value. They represent the end result, which is 9. Okay? All right, so these are the two expressions that we just came up with. They are equivalent expressions. Which or what mathematical property allows that expression on the right to look or be equivalent to the expression on the left? I want you to think about that for a second. What mathematical property allows the expression on the right to look like the one on the left? Turn to your shoulder partner and have a very quick conversation about that. It's one we've used over and over and over again as of late. Any idea? Yeah. It's the distributive property. So if I take this expression on the right here and I move the 12 in front like we had to do in some of the distributive property problems, or we didn't have to do, I just said for some of you that might be a little easier for you to see. Using the commutative property, I can move the 12 in front, and then when I multiply that out, I've got 12 times 1 right there. Well, the 12 times 1 leads us to this. And then we have 12 times 0.25. Well, of course, that leads us to this part right here. So it's the distributive property that actually allows us to think of those two things in an equivalent fashion there. Okay? All right. Continuing on. Number 2, Joe has a rope that is 25% longer than Larry's 12-foot long rope. How long is Joe's rope? Well, here's another very simple problem that if I gave you probably 15 or 20 seconds, you could figure out what that would be, but that's not the point here. The point here is we're trying to come up with equivalent numeric expressions that would allow us to find the answer. So I'm going to start this the same way. I'm going to break my tape diagram into 4 equal sections. Why 4? Because 25% is equivalent to 1/4. So Larry's original rope, or Larry's rope, is 12 foot long, and so I just set it up like that. But Joe's rope is 25% longer than that. So I'm going to take that tape diagram and add on another 25% to it. Well, of course, from Larry's rope, 25% is equivalent to 3 feet, and so that would tell us that his rope is 15 feet long. But I don't care about that. What I care about is coming up with equivalent numeric expressions that would allow us to find that. So once again, like in the last problem, we're going to think about this in 2 different ways. One way would be thinking about it in terms of starting with a 12-foot long piece of rope and then adding 25% onto that. And so if I start with a 12-foot piece of rope and add on 25% to that, that would give me that expression right there. The other way of thinking about that is you start with 100% and you're adding on 25% to that, so that gives us a piece of rope that is now 125%. And so that's where this expression comes from. 100% plus 25% as decimal values leads us to 1 plus 0.25. So we're finding 125% of 12. So the 2 numeric expressions, which is the important part of this problem, that's what we were trying to come up with, those 2 equivalent numeric expressions, okay? All right, those are equivalent expressions once again. Let's go to number 3. I would like all of you to try number 3. You are not solving anything. All you are trying to do is to write both equivalent numeric expressions that will help you find the answer to that. You don't have to find the answer. All I want to see are the 2 equivalent numeric expressions. All right, so let's take a look at number 3. Now, in number 3, and after that, I didn't draw any more tape diagrams for you. The tape diagram is just to give you kind of a concrete example to help you if you get stuck along the way. Now, I went ahead and I drew one. I broke it up into 10 sections because 30% is 3 out of 10. And so what that would make is if it was originally 12 feet, 12 into 10 equal portions, or 10 equal portions, is 1.2 per part here, and I'm trying to squeeze that in there. It's hard to write that exactly the way it is. Do my best here. Alright, so that is the 12 feet, and that is the 100%. But it increased 30% in the last 2 years, so that means I need to add on to this tape diagram essentially 3 more 10% sections, which of course would give me 3 more 1.2s. And then from there, once again, I'm not really concerned about the answer. I'm concerned more about the equivalent numeric expression. So I'm going to go about this the same exact way that I did in the other two. I'm going to take the tape diagram off here now. And one way would be to think about it in terms of adding 30% on. So that would be 12 plus 30% of another 12. And that's where we got that 3.6, those 3 1.2s at the end. That's one way of thinking about it. The other way is, if we add on 30%, that means we now have 130%. That's where the 1 plus 0.30 in parentheses comes from there. So the two, let me back that up one more time here. Those two red expressions, those are the two equivalent numeric expressions. Okay? The ones that we have in red right here. All right, I would like everybody to try number 4. And once again, in number 4, all we're trying to do is to come up with the two equivalent numeric expressions. If a tape diagram helps you, utilize it. So, just like the last one, I went ahead and set up a tape diagram. Some of you are using them, some of you are not. It doesn't really matter to me. Paulo's able to cut 20% off of his time, so we're essentially taking off the 20% right there. So that leaves us with 80%, and that really is the key to the problem here. But we're more concerned about the expressions. So if we are taking away 20%, that would be 260 minus 20% of 260, and those would be those last two 26s that I had at the very end there. And then the other way of thinking about it is that if you take away 20%, that leaves you with 80%. And so that's where the 1 minus 0.20 comes from. So the quantity of 1 minus 0.20 times 260. So it is the two expressions in red. Those are the ones we're looking for, and those are the two equivalent expressions. Okay? All right, I would like everybody to do number 5. So this is the first one that I'm actually not going to draw a tape diagram. First of all, because I don't want to, but secondly, the 14% longer, just the way that number is kind of makes it a little more difficult. It could be done with a tape diagram, but I don't want to. So Carly's is 14% longer than that. Could somebody give me one numeric expression that will work for this problem? Yes?
The quantity of 1 plus 0.14
Times 100 and what?
40.
All right, that works. Could somebody give me the other one that works for that? Yes.
140 plus 0.14 times 140.
Okay, so I'm going to change this problem really quickly, okay? What if I change this problem and it said Carly's is 14% shorter? All I'm doing is changing one word. Carly's is 14% shorter. Now what do the two expressions look like? Give me one of them.
1 minus 0.14.
So the quantity of that?
Yeah, the quantity of that times 140.
Okay. What would the other one be? And I'm doing this for a reason, and so you can see exactly what's happening here. Yes?
140 minus 0.14 times 100.
Okay, so if we're making it longer, we're extending the actual board 14%. Those are the expressions in blue. But if we're taking away 14%, like we're doing here and here, that means we are going to be making them short. So those are the two expressions in red there. And that idea sort of leads us into problems number 6 and 7. And so let me get that one finished. And this is where we're headed in a few months, dealing with lots of percent problems. And so number 6 says an item is normally priced at $400. The item is then marked up 23%. Every single item that you've ever purchased in a store, the store that you purchased it from purchased that item from somebody else, and they mark it up. That's how they make a profit. Okay? That's where the idea of markup comes from. If you go to Best Buy and buy something tonight, whatever you bought, they bought from somebody else, and they marked it up a certain percentage based on how much profit they want to make. So this is a perfect example of that. Well, the idea of marking it up is no different than the last problem that we did, number 5, where you were trying to figure out how long Carly's snowboard was, because hers was 14% longer. It's the same idea. And then in number 7, it says the cycle store has a bike regularly priced at $660, and Tom negotiated a 30% discount. Well, sometimes you go in the store and they're giving you a discount. And some people think of a discount as a mark down because they're taking the price that they normally sell it at and they're marking the price down a certain percentage. So while these two problems may seem different, they're really identical to the first 5 problems that we did. So I would like you to go ahead now and do number 6, 7, and 8. And number 6 and 7, these are the only 2 that we're actually finding the answers for today. All the rest of them after those 2, we're going back to just writing expressions, okay? So I want you to first write the 2 numeric expressions for number 6 and number 7, and then find the answer to both of those. And once again, for mark up, we're marking the price up. We're extending it out, if we want to think of it that way. For a discount, we're marking the price down or taking some away from it. We are finding a markup, and once again, markup is an amount added to the cost price of an item to cover overhead and profit for the store that's selling it. One possible numeric expression would look like this, based on what we were talking about in 1 through 5, and the other one would look like this. It's up to you from here, whichever one you think looks easier. I think the second one looks easier because I can add 1 plus 0.23 in my head, and then I just have to multiply 1.23 times 400, and that's fairly simple. That would be $492. In number 7, Tom negotiated a 30% discount, so that means you're taking away 30% from the $660. And once again, discount is an amount of money taken off an item. Sometimes a discount is called a markdown. And so one expression would look like this. Once again, similar to ideas we talked about in 1 through 5. Another one would look like this. And I think the second one is easier to deal with because we can subtract 1, take away 0.30 in our head. That's 0.7. Multiplying 660 times 0.7 is very simple, and that would leave us with $462. Any questions about either one of those? All right, and then number 8, it said to select or circle the 3 expressions from below that are equivalent. Which 3 are equivalent? Which 3? What? A, B, and C. Yeah. A and C look extremely similar to what we were talking about today, and then B comes from, of course, simplifying A. D has nothing to do with either one of them. All right, so we're going to do number 9 together, and then I'm going to have you finish off the rest, and then we will compare all of them with our shoulder partner. All of 9 through 17, you're simply trying to come up with an expression Some of them I think maybe ask for more than one, but most of them ask for just one expression that you could use to find the answer, but you don't have to solve it. So for example, number 9, Josh made 5 3-pointers and 4 2-pointers at his basketball game. Write a numeric expression to represent how many points he scored. It's not asking for how many points, just a numeric expression, so that might be something like 5 times 3 plus 4 times 2. Okay? You go ahead and finish 10 through 17. I'll give you about 4 or 5 minutes, and then we'll spend a couple of minutes going through those with our shoulder partner. All right, so we're about to shoulder partner all the rest of the problems, and the key is this. When you compare with your shoulder partner, what you want to make sure of is if your expressions are not identical, you need to take a look at both of them and discuss whether they are equivalent or not, because we've already seen that there's more than one way of writing something. So when you shoulder partner, if your expressions are not identical, discuss if they are equivalent or not. So this is going to probably take 2 or 3 minutes. Go ahead and shoulder partner all of 10 through 17. Go. All right, number 10, we have 2 apples for 30 cents each and 3 pounds of cherries for $1.75 a pound. One expression that would work for that would be 2 times 0.30 plus 3 times 1.75. Number 11, we have 20 chocolates and 25 red velvet cupcakes, or 20 chocolate cupcakes, and she gives each of her grandchildren a third of them, so either one of those would be okay. I know some of you had simplified 20 plus 25 to 45, and that would be fine as well. Number 12, we have a sweater for $25 and a pair of pants for $40, and they have a 25% off coupon. If there's 25% off, that leaves 75%. So here's one way of writing the expression, and here is another way of writing that expression, similar to what we talked about today. Somebody brought up third period about, well, shouldn't it be 0.25? And the answer is no. If you get 25% off, you're taking 25% away from it. That leaves 75%. And so if you had, in place of 0.75, 1 minus 0.25, that's fine. I just went ahead and I simplified it. Number 13, 2 candles for $3 each and 3 books for $7, and we have 20% off, so that leaves 80%. So here's one possible expression, and there's another possible one. And of course, you could replace 0.8 with 1 minus 0.20. Number 14 would look something like this, because they get 15% off. If you get 15% off, that leaves 85%. You could, of course, replace 85% or 0.85 with 1 minus 0.15. Okay? And number 15 could look something like this. $12. You take away 5 days of $2.15 a piece, or each. Number 16 should look something like this. $6, and then take away the 4 candy bars at 75 cents each. And then number 17, 20% off coupon leaves 80%. So that, or putting it all together in one, looks something like this. All right. Any questions? We are finished for today.